We're going to talk about 3 different kinds of reactions. The first one is a combustion reaction. We've talked about this a little bit already. In a combustion reaction, we have a reaction with oxygen. It's going to react with oxygen. It's going to create an oxygen-containing compound, often including water, and combustion reactions also emit heat. We have personal experience with that. You light the Bunsen burner, you're combusting natural gas, it gets hot. It's releasing heat. If our compound has carbon, hydrogen, and oxygen, or just carbon and hydrogen, the products are always the same for complete combustion. We always get carbon dioxide and water. So you may need to write chemical equations for combustion. They'll give you the formula of one of the reactants. The other reactant is O2. The products are CO2 and H2O. So this is natural gas reacting with oxygen to form CO2 and H2O. Write a balanced equation for the complete combustion of liquid C2H5OH. So I'm going to write down the reactant that they gave me, C2H5OH. Sometimes the problem will say to include the state symbols. Other times it doesn't mention it. You only have to include them if it says. I'm going to include them here just for practice. I'm told that this is a liquid. What's the other reactant for combustion? Oxygen. It's O2 because oxygen is a diatomic element. And what are the products? CO2, CO2, which is a gas, and water. And this will be a gas also because these reactions are hot, and so the water will be in the gas state. Okay, so now we're going to start balancing. It often works to just start at the left. So my first element is carbon. There are 2 carbons on the left side. What do I need to do to balance the carbon on the right side? I need to put a 2 in front of CO2. Right? So I have 2 carbons here, and I have 2 carbons over here. The next one is hydrogen. Okay, well, this compound has hydrogen in 2 different places in its formula. There's a reason for that, but we don't need to worry about it. But this is 5 plus 1, that's 6. 6 hydrogens. And so no hydrogens in this one. How do I get 6 hydrogens out of H2O? I'm going to put a 3 here, right? So if I have 3 of these, then I have 3 times 2, 6 hydrogens. Now for oxygen, I have an oxygen here, and I have 2 oxygens there. So that's 3 oxygens. And what do I have going on over here? Well, 2 times 2, I've got 4 there, and I've got 3 over here. 4 plus 3, so I've got a total of 7. So before, we had something like this where we had an even number like this and an odd number over there. But what we need to think about is our oxygens are spread out, right? So maybe I should have written them spread out. So this is 1 oxygen plus 2 oxygens is giving me 3 oxygens. I want to make this total 7. I really don't want to put a coefficient on this one because that's going to change carbon and hydrogen, and then I'm going to go in circles. right? I'm going to have to change a whole bunch of things. But if I put a coefficient in front of the O2, I can fix the oxygen without messing anything up. Since I have 1 over here, that means I need to have 6 here, right? So if I have 3 oxygens, then I'll end up with 7. Any questions? Now, we did that example where we had the little Erlenmeyer flasks and the little pictures of molecules, and I drew circles around them. If you have trouble balancing equations, you can get creative with gumdrops or M&Ms or something and say, okay, the blue M&Ms are carbon. I've got 2 of those over here, and then I've got 5 white. Well, some packages have white. Let's say green hydrogens and a red for the oxygen. And then I've got 2 red ones for the oxygen here. And then I'm going to have a line. And then over here is what I'm making. And I need it to work out so that I can take these pieces and make evenly the correct number of pieces over there. I need them to match up. So if you're more of a kinesthetic person, that might be a way to help your brain understand what this is doing. Alkali metal reactions. The alkali metals are very reactive, and so they will react vigorously with nonmetals. So here we're giving a generic equation. We're using M to stand in for one of the alkali metals. We're talking about like sodium and potassium, those guys. React with halogens, and we're going to use X to represent the halogens. The halogens are group 7, fluorine, chlorine, bromine, iodine. And they're going to react and form an ionic compound. So this is what happens when you react chlorine and nitrogen. You get sodium chloride from this, kind of exciting and dangerous little green reaction there. Reactivity increases as you go down the group. So rubidium is going to be more reactive than sodium. Alkali metals can react with water. And they will do that in this way. The metal reacts with water, and it forms a dissolved metal ion and hydroxide ions and hydrogen gas molecules. These reactions are highly exothermic and can be explosive because the heat from the reaction can ignite the hydrogen gas. So this is showing lithium and sodium and potassium. They get more reactive as you go down, as you see the potassium is actually, spitting out sparks and stuff, where the lithium is just kind of fizzling peacefully to itself. Halogen reactions. The halogens are very reactive nonmetals. So they will react with a lot of metals to form metal halides. And that formula here is going to be based on what kind of an ion the metal takes. Halogens can react with hydrogen to make hydrogen halides. So this hydrogen halide here could be like hydrogen chloride. As a covalent molecule, it's a gas in its pure form. But when you put it in water, it forms an acid, and that's what we're I lost my word. More used to. So this is an example. We don't need that. Writing equations like this can be challenging for beginning students. The only as of this point, the only equations that you need to be able to write are for combustion. Okay, you should be able to write a combustion chemical equation and balance it. Reacts with oxygen, forms CO2 and H2O. But let's just go through these quickly. It says, let's look for the reaction between aluminum metal and chlorine gas. So aluminum metal, so aluminum's a solid at room temperature. What's the formula for chlorine? Cl2. And it says it's a gas, also the periodic table. So without having memorized those types of reactions, they're like, I don't know. Well, this is going to make a compound, and it's going to be a metal and a non-metal. What kind of a compound is that? Ionic compound. What's the formula for the compound that forms between aluminum and chlorine? We can do that. What kind of an ion does aluminum make? 3+. And what kind of an ion does chlorine make? Cl-. So how are those going to go together? Well, we'll put them together so their charges add up to 0. So this is going to be AlCl3. I wouldn't necessarily expect you to know this, but this would be a solid because ionic compounds like table salt have very high melting points. Now, if given this, you should be able to balance it. Here we have an aluminum and one aluminum. That's great. Here we have 2 chlorines and 3 chlorines. That's that odd-even problem. Let's double the odd number. Let's put a 2 here. Of course, that messes up the aluminum, but we can fix it. A 2 over here. And then how many chlorines do we need? 3. There we go. The reaction between lithium metal and liquid water. So lithium is Li, and that's a solid. And that says we're reacting with water, which is a liquid. And again, it told us in one of the previous slides what this forms, but I don't expect that you would remember that. It's going to form a lithium ion. So what charge does a lithium ion have? +1. Now this is in water, and it's an ion, so I'm going to write this as aqueous because it's dissolved in the water. It's also going to form hydroxide ions, because that's what it said. Those are aqueous. And hydrogen gas. That's what went boom. Let's balance it. So 1 lithium and 1 lithium. So that's fine. Here I have 2 hydrogens and 3 hydrogens. 1 oxygen and 1 oxygen. This one can get a little tangled up because we have hydrogen and oxygen together in both these places, right? Well, if I double this one, that gives me 2 oxygens, and I could double this one to have 2 oxygens. And now, how does that work out with the hydrogens? I've got 4 hydrogens and 2 plus 2, 4 hydrogens. That one's a little trickier. The reaction between gaseous hydrogen and liquid bromine. What's the formula for gaseous hydrogen? H2. It's a diatomic element. What's the formula for liquid bromine? Br2. Horses need oats for clear brown eyes. It's also diatomic. And then we have to figure out, what does this make? Well, have we seen compounds between hydrogen and bromine before? We saw acids, right? So what's the acid that has hydrogen and bromine in it? Hydrobromic acid, which would be HBr. Because when this dissolves in water, we have a -1 ion and a +1 ion. Now this is not occurring in water, so I'm not going to call it an acid. This is actually going to be a gas. I don't expect you to know that. How do I balance this? Put a 2 over here. So 2 hydrogens, 2 hydrogens, 2 bromines, 2 bromines. Any questions?